Hello, my name is Angelica Coriano. I'm a student at Valencia College in the Bachelor's for Electrical Engineering Technology degree. This is my video submission for lab number 4 for Digital Systems, which is CET 2114C for Professor Evans. This video is going to include parts 1, 2, and 3. The timestamps will be in the description box, beginning with part number 1 right now. With part number 1, we were put to build this circuit here that I'm going to show, which is an XOR gate with switch 1 connected to input A and switch 2 connected to input B. And I have my circuit right here, and let it focus. I'm going to start going through how it's wired right now. So in this circuit, which I'm going to start high and come back in, I have chip number 7486, which has the XOR gate, exclusive OR gates. Pin 1 is connected to input A, which is switch 1, so pin 1 here is just bridged and bridged and bridged again till it gets to switch 1. So that's switch 1 for pin 1. Pin 2, which is the second wire right here, is bridged and bridged again to switch number 2. So once again, that is pin 2, which is input B in this circuit, is connected to switch 2. Pin 3, which is the output, is connected right here, and it is bridged to LED number 1. So LED number 1 is connected here at input at pin 3, which is the output. And then we have pin 14 connected to the positive VCC, which is 5-volt VCC. Pin 14. And pin 7 connected to this ground, which is coming from the power supply. And that is how my circuit is wired. Now, beginning with part number 1, it says to build this circuit, connect switch input A to switch 1 and input switch 2 to input B, which we've already done, and output Z to an LED, which is also already done, which is what I showed in the circuit, in my circuit layout. And we're going to complete this truth table right here. So A and B are 0 and 0. Let me show that one. 1 and 2, 0, 0. My LED number 1 is 0. So that output is 0. Next we have 0, 1. So I'm going to come here at 0, 1, and my LED turned on, so that is a 1. Now we have 1, 0, so I need to hear 1, 0, and my LED has also turned on again, so this is 1. Next is 1, 1, 1, 1, and my LED has turned off, and that is the truth table for the exclusive OR gate. So now beginning with part E of letter E of part 1, we have here, it says remove input B from switch 2 and connect it to a 1 Hz square wave. Alrighty, so I have my 1 Hz square wave here. The circuit is exactly the same. The only thing I did is I disconnected, let it focus, pin 2 from the switch, which I had here, and now it is connected, bridged here, to the 1 kilohertz. So 1 kilohertz, bridge there to pin number 2. Pin number 1 is still bridged to switch number 1. Switch number 1. The output, which is right here, is pin 3. Just trying to show the difference. Yep, the output, which is right there, which is pin 3, is still connected to LED number 1. Another thing we have to do is show the 1 kilohertz signal, the 60 hertz, 1 hertz clock signal, and an LED, which I'm going to do right now. I'm just going to try to take the video of it happening. I'm going to connect to LED number 3 just to have a little bit of distance there. And then I'm going to bridge it here in the same row where I have the 1 Hz signal. So now that row, besides the clock signal and it connecting to pin number 2 and becoming input B, is also now connected to LED number 3. And that is how the circuit is built there. So now it's asking us to make a sketch showing the square wave input signal Z when output A switch 1 is high. So I'm going to turn this on. This is my LED. Oh, that's pretty cool. I'm going to turn these both low because I only have one input here now. So it says 4-1 showing square wave and input signal when switch A, input A is high. So I'm going to put it high. So, okay, cool. Anytime the square wave is on high, the output is low. And anytime the input is on low, the output is high. And that is because we have one input consistently high, and with the exclusive OR gate, only one input can be high for the output to be high. So when this one goes low, when the clock signal goes low, it will go high for the output. And when the clock signal is high, it goes low. And that is it when the input A is high and input B is that square wave. So now moving on to part H. It says make and sketch a graph showing the square wave and output Z when the input A is low. So I'm going to come here. I'm going to put switch 1, which is input A, to low. And now they both blink at the same time, and that is because one input is consistently low, and for an exclusive OR gate to have a high output, one of the inputs has to be high. So anytime the square wave goes high, the output will also be high, because that's the only time it will receive a 1, since the input A is consistently 0. And that's how that looks. So beginning now with part number 2, we're going to be building this circuit right here, which is an XNOR circuit made of XOR gates. So this is the circuit I have built here, and I'm going to start explaining how this is wired up right about now. Now showing this circuit here, I have pin number 10, which is input A. They're all orange wires, but I'm going to try to wiggle it a little bit so you can see. So this wire is connected to this one and bridged to switch number 1. So switch 1 connects to pin 10, which is input A. Input B, as you can see here, I'll get it sideways. Input B is connected here to switch number 2. So switch 2 goes here into input B. So it's pin number 9. So pin 10 is input A and is connected to switch 1. Pin 9 is input B and it's connected to switch number 2. Then we have the output right here, which is pin 8. Pin 8, so I'm going to wiggle from that side. Pin 8 is coming in this way and is one of the inputs. It's input B for another exclusive OR gate. And input A for the exclusive OR gate is going to be this VCC. So it's connected to the 5-volt VCC. Is input A on this other exclusive OR gate, and the output of the first exclusive OR gate is now the input of the second exclusive OR gate. And the output, so this is pin 1, 2, 3, 4. Pin 4, which is input of the second gate, is connected to VCC. Pin 5, which is another input of the exclusive OR, is the output of the first exclusive OR gate we're looking at. So pin 8 connected to pin 5. And then pin 6, which is the output of this second exclusive OR gate, is bridged to LED. I put number 3 just for the ease of being able to bridge it as close and as comfortably as possible. And then I have again pin 7, connected to ground, which is connected to this ground, and pin 14 connected to the 5-volt VCC, which is also connected to pin number 4 because it's one of the inputs. And that is how this circuit is wired. So now we're going to begin continuing with the part 2, letter E, which is data inputs. So you're going to start A and B is 0, 0, 0, 0, and my LED is on, so that's a 1. Now we have 0, 1, 0, 1, and LED number 3 is off, so that is a 0. Now we have 1, 0, 1, 0, and LED number 3 is off, so that is going to be 0. And then we have 1, 1, 1, 1, and the LED is on. So for 1, 1, the output Z is going to be 1, and that is the truth table. So now moving on to part F, it says remove input B from switch 2 and connect it to a 1 Hz wave. And I have that here. The only difference I have between this and the other circuit is that I remove switch 2, and now I have my input B, which is pin number 9. I'm gonna let it focus. Input B, which is pin 9, I'm gonna move these things out of the way, is connected to the 1 Hz square signal. So 1 Hz square signal connected to imp pin 9. I'm gonna show it on the side. There we go. So pin 9, which is input B, is connected to that square wave, and also on that square wave is connected LED number 3. Another move I did was that I connected LED number 3 to the 1 Hz, and then I took the output of the second XOR gate, which is pin number 6, and I connected it to LED 0. And that is how my circuit is set up. Pin 10 is still connected to switch number 1, which is input A. Pin 4 is still connected to the VCC. Pin 5 is still the output of the first XOR gate, which is pin number 8. It's still connected to pin number 5. The only difference is now that pin 6 is now connected to LED number 0. And then LED number 3 is now connected to that 1 Hz square wave. And that is my circuit. So now beginning with this, it says make a sketch and graph 4, 3 below showing the square wave and output Z when input A is high. So I'm going to turn this on and I'm going to put input A as high. And they are blinking at the same time. I apologize. Yes, they're blinking at the same time because this circuit is creating an exclusive NOR gate. So in an exclusive NOR gate, for the output to be high, both inputs must match. Since the input A is consistently high, the output is only going to be high when the square wave signal is high. So that's why they're blinking at the same time. So when one input is consistently high and the other input is the square wave, the output will only be high when the square wave is high. And number 2 is now saying show input signal when input A is low. So I'm going to move this to low. And now they're opposite because, once again, for the XNOR gate, the inputs must both be the same value, not just high. I might have said high earlier, but they have to be the same value for the output to be high. So in the last one, since input A was high, anytime the square wave was high, the output was also high. That's why they blinked at the same time. But now, since the input is consistently low for input A, anytime the square wave is low is when the input will be high because they will match 0 and 0. And that is why they're blinking at opposite directions, well, opposite times. So explaining now how this circuit is wired. I'm going to use the pen to try to guide. Switch 0 and 2 are A1 and B1. So A1 is connected to pin number 4, which is the entrance to one XOR gate. So that's pin 4. That's A1. The next input, which is pin 5, is B1. And that is switch number 2. So A1, B1. That's going through an XOR gate. 1 and 3 are A2, B2, and they're going through an XOR gate. So A2 is connected here, goes here, do that one, and is connected to pin number 9. That's A2. B2, which is this yellow wire right here, is connected here to switch 3. So A2, B2. B2, be connected to that yellow one, and it's in pin number 8, 9, 10. It's in pin number 10. And pin number 9 is connected to switch 1, which is B2. Alrighty. Now, so my gates that I'm using are right here. Pin 4, pin 5, pin 6, pin 8, 9, and 10. So pin 9 and 10 are inputs. Pin 8 is the output, and it's connected to another XOR gate with the positive VCC to make an XOR gate. So it's pin 13 is connected to the positive VCC. Pin 12 is connected to the output of pin 8, which is the output of that XOR gate. And the output of this XOR gate, which is pin 11, is connected to an AND gate, to pin number 10 of this AND gate, which is input A of the AND gate. In this XOR gate, which has A1 and B1, the output, which is pin number 6, which is right here, this brown wire, is connected yet again with a positive VCC. So pin 2 of this 7486 chip, which is its own exclusive OR gate, is the output of the other exclusive OR gate, which is comparing A1 and B1. And pin 1, which is input A of this second exclusive OR gate, is the positive VCC. The output, which is this orange, is going to this AND gate where the output of the other comparison is also entering. So pins 8 and 9, pins 9 and 10 are the inputs to an AND gate. Pin 8 is the output of the AND gate, and that one is connected to LED number 2. And that is how this is wired. So now we're going to go through this truth table. I'm going to turn my circuit on. Oh, woo. LED number 3, which is the output. So we have 0, 0, 0, 0. 0, 0, 0, 0. The output is high. Now we have 0, 1, 1, 1. 0, 1, 1, 1. The output is low. Now we have, it's low, 1, 0, 1, 1. So 1, 0, 1, 1. 1, 0, 1, 1. And the output is low. Now we have 1, 1, 1, 1. And the output is high. describe the function of the circuit. Look at the input supplied and the output observed for table 4.3. Determine what this circuit accomplishes. So what this circuit is accomplishing is comparing A1 and B1 and A2 and B2. If these values match, then it's going to give you a high output. If they don't match, it's going to give you low. So basically, if you were to have a number that was A1, A2, and B1, B2, and you were trying to build a circuit that compares, and anytime A1 and A2 matches B1, B2, it'd give you a high output.